What's up, engineers? Welcome back to another session of Root Professor Intro to Power. Now, today we are, as the title states, we'll be talking about power. Power has really different definitions in different disciplines, but the concept essentially is the same. The concept is how fast one form of energy can be converted to another form of energy, how quickly one type of energy is converted to another type of energy, and there's a component of time there, right? So here we're talking about electricity, electronics. So in that regard, you can see in green there's a person here doing or pushing rather, all right, symbolizing force or voltage. And when you have voltage applied to a conductor, which is symbolized by this black tube here, and you have these negative symbols, which are electrons. When you have a voltage or a force applied to a conductor, these electrons begin to move, right? These electrons begin to move. So you have electrical energy, force is being applied to electrical energy, and this electrical energy is connected to a lamp. Now, when these electrons reach the lamp, guess what happens to the lamp? Yeah, exactly. The lamp starts to glow, right? The lamp illuminates, lights up. So here you have electrical energy being converted to heat and light energy. That's basically what power is. Conversion of one type of energy to another type of energy in a given amount of time. Power is measured in watt, right? Power, the unit for power is measured in watt, or the letter W, right? Coming up, we're going to go over the circuit, we're going to go over the formulas, and we'll analyze the relationship between voltage, current, and power. We're going to be using the P is equal to V squared divided by R formula, all right, to find our power. Why not use the green or the red formula? Why not use P is equal to V times I, or P is equal to I squared times R? Well, you probably guessed it. The formulas have the current in it, and we don't have current here. So we can't use the green or the red, unless there's a quick hack, right? You can get around it if you use Ohm's law to find the current, right? Because you have the V, you have the R, right? You have the V, you have the R. You can find the current using Ohm's law, and then apply one of those formulas. But let's try to use the blue formula and see how it works out. All right, so my formula goes something like this. P is equal to V squared divided by R, right? And we substitute the numbers for V, so it will be 10 squared, and R is 1,000, and we get 0.1 watt, right? 0.1 watt, 0.1 watt. Or you can say 100 milliwatt, right? 100 milliwatt. So that's my answer. But let's analyze this a little further. All right? What happens if you double your voltage? Let's say you double your voltage, all right? Now check this out. You're probably not thinking much about it now, but when you have to pay the electric bill, doubling the voltage dramatically changes the power consumption in your home. All right, so your electric bill, do you think your electric bill will double if you double the voltage? Let's double the voltage to 20 volts. Right, so let's make the new voltage 20 volts. All right, so let's double the voltage to 20 volts and see what happens. We'll keep the load the same and we'll see what happens. I'll do this in red. So remember, my voltage is doubled, right? So P is equal to V squared over R. Same setup. My V squared is 20 now, like 20 squared. All right. And my resistance is still 1,000. That's my load. And look at what happens. What do you think the power is going to be? It becomes 0.4 watts or 400 milliwatts. Whoa. Right? 400 milliwatts. Look at the change. You think if you double the voltage, your power doubles? No. Your power consumption quadruples. Quadruples. All right. Why is that? Well, look at the formula itself. The formula lets you know if you double the voltage, the power doesn't rise, uh, just doesn't double. It goes up exponentially, right? It squares it. So doubling the voltage will quadruple your power consumption. So now we'll take the voltage and cut it in half. In the past, we doubled it to see the power consumption quadrupled. Now we'll take the original voltage and cut it in half. So now my new voltage, my new V, is going to be 5 volts. Alright, so let's see how our power consumption changes if our voltage is cut in half. My power formula does not change, stays the same, right? So we sub in for V, which is 5 squared is 25. 25 divided by 1,000. So what do we get? We get power is equal to 0.025 watts, right? Or 25 milliwatts. That is a quarter of your original power consumption. So originally it was 100 milliwatts, now it's 25 milliwatts. Just think about the massive savings in your current bill. Now we're gonna focus on the other two formulas. This one, P is equal to V times I, and P is equal to I squared times R. And as you can see, I have a circuit here. It's a little blurry, so I'll just clarify the numbers here. It's 440 volts. This is 8 amps. This is a current. This is resistance, is a question mark, and power is also a question mark. All right, so let's get to it. So first we'll use this formula, P is equal to V times I, and figure it out. By the way, R is missing here, so we can use Ohm's law to find R, or we can use this formula to find R as well. And I'll show you how to do that at the end, towards the end. Let's get to it. So P is equal to V times I, right? And you know, power is the product of voltage and current. So we plug in our numbers, 440 times current, which is 8 amps. What do you get? What do you get? What did you get? Well, I got 3520 watts, all right, or 3.52 k watts. 3.52 kilowatts. Now, how do we know this is the correct answer? Why don't we plug this number in and flip this formula around to see if it makes sense? Let's do that, right? So P is equal to V times I. Let's say we want to find I. What do we do here? Well, we have to get rid of the V, right? So what do we do to get rid of the V? We divide the V by both sides. So we cross this V out and the V ends up here. So my I is equal to P over V. Let's do the check. Let's see how it works out. My P, remember, is 3520, and my voltage is 440, right? And when you do this, when you divide 3520 by 440, what do you get? Well, I got 8 amps. All right, so my answer checks out. This answer checks out. So now we're gonna focus on the formula P is equal to I squared times R, which is boxed in red. All right, so let's get that going. P is equal to I squared times R. My I squared is going to be 8 squared, and my R is going to be, well, hold up, R is not given. So we have to find R first. Now, how can we use the power formula to find R? We're going to have to use a little bit of algebra magic, similar to what we did here, right? Very similar to what we did here, guys. So let's get to it. P is equal to I squared times R. We are not looking for P anymore. We already have P. We are looking for R. So how can we get R by itself? Now the R is attached to the I squared with this multiplication symbol, right? So we need to get rid of the I squared. So what do? We divide the I squared from here, right? And whatever we do to one side must be done to the other side. So now my R is equal to, the formula for R is equal to P over I squared. Alright, so my P is 3520, and my I squared is going to be, well, 8 squared is going to be 64, right? 64. What's my R? My R turns out to be 55 ohms. You guys should work this out on your calculators and verify it. No worries though, we'll verify it in a little bit anyways. Okay, so that's my R. Does that make sense though? Is that R really accurate? Let's do Ohm's law and see if it works out. And we'll use blue for Ohm's law. So R is equal to V over I, right? What is my voltage? My voltage is 440. What is my I? My I is 8. So what should we get from my resistance? Work it out on your calculator, see what you get. I got 55 ohms. So my answer, whoa, that's a new angle. My answer checks out. I got 55 ohms here, 55 ohms here. And I used the original power formula. I converted the power formula into a formula for R, right? R is equal to P over I squared. And then I used Ohm's law. To verify my results. So I did a check. First, I used a power formula to find the missing variable, and then I used another formula to make sure that missing variable was correct. So we went over quite a few things today, guys. Sorry about that. We went over quite a few things, right? We went over all the formulas. I have provided the Ohm's law power chart here. It's called the wheel formula chart. It's also on Google. You can Google it and check it out yourself. We went over the Watt's law. We did the Watt's law analysis, right? When you double the voltage, you quadruple the power. When you cut the voltage in half, the power is a quarter of whatever it was originally, right? We took the power formulas, we reconfigured it to find or suit our needs, and we performed our checks to make sure our answers and solutions worked out. If you have any more questions, leave me a comment, shoot me an email, whatever it is, let me know. I hope this was helpful. I hope to see you guys again soon. Ta-ta, bye-bye, one love, and as you guys know, stay safe. It's COVID season out there, so be cool, be chill. See you guys soon.